right, we're looking at question, check for understanding number 1, page 58, example 1. A piece of cardboard 30 centimeters long, 25 centimeters wide is used to make a box with no lid. Equal squares of side x, side length x centimeters are cut from the corners in order to make the ends fold up. So I've drawn here a rectangular piece of cardboard, and in order to make this three-dimensional box, this blue box down below, we're going to need to cut the corners out so that the flaps can be folded up to actually hold a volume. So I drew a jagged line here in each corner. That's the corner I'm going to cut out. And just like the question says, we're going to let the length of each of those cuts be x centimeters. So I'm going to label each of these pieces as a dimension of x by x being cut out. We know that this original length was 30 centimeters, and we know this original width was 25 centimeters. Okay, so now once we cut out those corners, obviously the length and widths will change. So if we're working with volume, so let's just type out volume is equal to length times width times height. And now let's make our changes according to the equation. So volume of this particular box would be the length, which was 30, but now the 30 is lessened by 2 x values. The width, which was 25, is lessened also by 2 times whatever x is. And the height, well, if you fold these flaps up in these corners, the height on the side here will be x. So I've written a polynomial function to represent the volume of the box in factored form. Part B asks us to graph the function, and it states what's the domain. It would be a good idea perhaps to answer that question as to what the domain is before we graph it. If we look at this function, what values would make the binomial 0? Because those values cannot exist, as if we have a length and width of 0, we don't have a volume. So if you look at this first binomial, we can see that 30 minus 2x, the root for that would be 15. So you can't have a length greater than 15, because that would make this length negative. Over here, for the width, 12.5 would make 2x 25, so x cannot be bigger than 12.5, or we have a negative width. So 15 and 12.5, since x is common for both, we can now state that the domain must be x has to be greater than 0, because you can't have a negative number, and at the same time x must be less than 12.5. It can't equal 12.5, because then we wouldn't have a width. Now let's graph the function. So I've already started typing this into my graphing calculator, this volume function. There it is. Okay. If I now just leave it as a 10 by 10 grid, zoom standard, you'll notice that we won't see anything up on the screen. So the graph is out there somewhere. We need to change the window in order to find it. So what we have here is a domain of 0 to 12.5. So let's go to the window. Notice that x is max is 10 right now. So since it can't be greater than 12.5, let's just change it to a number like 19 or 20 in order to see more of what's happening on the right. I'm going to press graph now. Okay, so part of this curve is now on the screen. Remember, this is a cubic function. Okay, so just review with me. A cubic function is going to have 2 critical points. It's either going to go up and down like that, or down and up and down like that. Okay, so one of the two. And because the lead coefficient is positive, it's going to be this one on the right. Okay, so that'll be its general shape. So that'll help me change the window. So let's go back here. Looks like the critical point up high here is far up the screen. So just by guess and check, I'm going to change the Y maximum to a number like 500 and just press graph to see where that fits. Okay, now it's looking like that cubic function that I had thought of. We'll definitely need to change the Y values to a higher maximum though. So looks like the peak is going to be up here. Let's put 1200. Okay. Do I have my maximum? Oh, almost. Okay, let's change the window one more time. Let's go to 1700. How does that look? Okay, I've got the maximum. I've got a valley here. So let's take a picture of that and sketch that here for part B. Okay, now it's asking for us to the nearest cubic centimeter to state the maximum volume of the box. Well, the maximum volume of the box, you guys need to be responsible for being able to do that graphically. So back to our graphing calculator, the maximum occurs right here. So you use the second function trace command for maximum. Press enter. There's a maximum hill right here. So go to the left, a left boundary, press enter, somewhere to the left of that maximum, and then go to the right, somewhere over here, press enter twice in a row, and you get approximately 4.5 and 1512. Okay, so for part C, let's write that in here. So for part C, it's roughly 4.5, and remember that's x. X is 4.5, and the Y value in this case was the volume. So V, the maximum volume, turned out to be 1512. Okay, so back to the question. They wanted to know what's the maximum volume. So the maximum volume is 1512 cubic centimeters. What size of square should be cut out to create this box? X was the single dimension of the square, so it'd be 4.5 by 4.5. And to the nearest 10th centimeter, what would be the dimensions of the box? Well, to get to the dimensions of the box, you would utilize the expression for volume that you had originally. So, for example, the length would be 30 take away 2 times x, and we said x was 4.5, so it'd be 30 take away 2 times 4.5, which would equal 30 subtract 9, the new length that would enable a maximum volume of 1512 cubic centimeters. The length that you would want to build this at would be 21 centimeters, and the width, I'll just do this by mental math, width would be 25 subtract 2.5, subtract 2 times 4.5. 2 times 4.5 is 9. 25 take away 9 would be 16. So the width would be 16. So if you wanted to, you could check your answer right now. You could check to see if the height of 4.5 multiplied by the length of 21 multiplied by the width of 16, those three numbers should multiply to give us what? They should multiply to give us the volume of 1512. Let's just double check to make sure that that is indeed the case. So here goes nothing. 4.5 times 21 times 16 equals. Well, doesn't that feel good?